Today we'll take a look at some common distributions or ways that data tends to group itself in various data sets. Okay, and there's four main types that we're going to look at today, and then we're going to try and make some connections between common distributions and spread, as well as measures of central tendency. But to start off, we'll do some quick warm-up here, again looking at sampling technique and bias, and those are things that we had done earlier on in this particular unit. So just very quickly, we want to identify the sampling technique that's used in each of that's used in the following, as well as the type of bias that's present, and explain how it could be removed. So for the first question, it says, coaches of the senior boys football team had 4 tickets to take students to a Toronto Argonauts game. To choose who got to attend the game, the coaches put each player's jersey into a bag and then pulled out 4. Okay, so the population that's being sampled here is the senior boys football team. Everybody has an equal chance. They're putting all of their jerseys in, and then they're just pulling out 4. So this is actually just random. Okay, so the coaches have no way of knowing who these 4 people are going to be. They're just randomly selected by pure luck. Okay. The second part here, the warm-up says, identify the type of bias present and explain how that bias could be removed. So the question says, taking into consideration the need for the board to find a minimum of $4.6 million in savings due to a budget deficit, and given that no school will change more than 20 minutes, do you support the board moving forward with the proposed changes? This is in relation to bell times and is why high schools start so much earlier than elementary schools. This question is actually a classic example of response bias because in this instance, the school board's question really is, do you support the board moving forward with the proposed changes, i.e. changing the bell times for high schools, making them earlier, and starting elementary schools later? That's the question that they want. But they're prefacing it, they're putting this information at the front by talking about the budget deficit and how much money they need to save, and that no school is going to change more than 20 minutes to try and influence the final result. So even the school board itself is guilty of bias when it comes to doing surveys, and that's clearly demonstrated in this particular example. So we're going to take a look at different common distributions, and I said we'll look at 4 of them. So we'll just start off taking a look at some of the definitions to begin with here. So common distribution is just where data tends to cluster within a data set. Okay, so the first row here that we'll look at deals with what we call a normal distribution, and the graph here on the right is a great bell curve. Okay, and so normally what this means that the data is evenly distributed around the mean. Okay, the mean, the median, and the mode are all relatively in line with each other. They're pretty close, pretty accurate. Okay, and so because the mean, the median, and the mode are really close, it means you've got about 50% of people are on the left-hand side of the bell and 50% are on the right-hand side of the bell. Okay, and so that's what we refer to as a normal distribution. That is ideally where things would be in a perfect world. The second row here indicates what we call a skewed distribution. These are again relative to the mean. Okay, and so a skewed distribution, it looks like a normal distribution that's been moved to either one side of the mean or the left. Okay, so you could have what's called a long tail or a right skew, or you could have a long tail for a left skew. Okay, and so the mean, the average of the data hasn't changed either way, but where those marks are distributed or where those values are distributed, they may be clustering to one side of the mean versus the other, and that could skew the data either side, and hence it's called a skewed curve. Okay. The next one is what we call a bimodal distribution. Okay, and in a bimodal distribution, you actually have 2 different peaks. Okay, so it kind of looks like a humped camel in a way. Okay, and they're relatively symmetrical on both sides of the peaks, but you actually have 2 peaks instead of 1. So it looks like a bell curve or a normal distribution that's been split in half and then put on both sides. Okay, so bimodal has this two hump shape to it, pretty distinctive. And then the last one that we'll talk about is what we call a uniform distribution. Okay, and that's where all of the data sets across the ranges are relatively even in value. They're very, very close. Okay, and so the mean and the median are at the center of the data. They're right in the middle. But again, what you have is a very even and very consistent set of data. It would be like, for example, if out of a class of 20, uh, you know, most like 19 of those kids happen to be getting, 74%. Just happen to be that way. Okay, and so that's a pretty normal uniform. Sorry, that's a pretty uniform distribution.